I guess we'll get started. Everybody's here kindly. Welcome to the Idaho Museum of Natural History. I'm Terry Bergmeyer. I'm the Director of Development here at the museum. My role is philanthropy and making sure that the museum is able to meet its financial goals. And a part of that is engaging our members in our community. And so this lecture series is kind of fun because that's what we feel we're doing, is we're bringing people into the museum that maybe haven't been here for a while. Maybe it's your first time. So welcome. We'll leave the gallery open afterwards if you want to tour our current exhibits. We have our buzzsaw shark, the Helicoprion, and we have an alpha, what is it? It's an alphabet. It's a sharkabit. Alphabet, every letter of the alphabet has a shark. And then we have Edson Fichter, which is actually what this lecture series is titled after, is Discover the Naturalist Within. So we hope that kind of stimulates something. Obviously it has. We have a good crowd tonight. Thank you. And the other piece, my role is if you would like to get a copy of our newsletter, know more about what's going on in the museum, please feel free to sign up. You can always unsubscribe, but it is a way to stay in touch with the museum on a monthly basis about our lecture series, about all the kids programs. We really have a strong STEM program right now for kids. So if you're interested in STEM education for your children, this is the place to get it done. And then here are some memberships. Membership is a big part of, there you go. Membership is a big part of how we support our exhibits, our programs, and again, just stay in touch with you and let you know what's going on in the museum. So those are here. If you have any questions about the museum, myself is here, and Teresa is in the back. Teresa Henderson she's kind of our do-everything gal, and she is here this evening also and can answer any questions you might have. This time I'm going to turn it over to Chuck, and Chuck was instrumental in saying from the beginning, he helped us curate, I guess, the Edson Fichter exhibit. And new Edson and a whole committee of people helped us put that exhibit together. So he kept going, we've got to have a lecture series, we've got to have a lecture series. And so, by golly, yeah. So thank you, Chuck, and I'll turn it over to you and let you introduce our guest.
Okay, well, we're really lucky to have Dr. Scott Bergen speak to us tonight. He's a spatial ecologist with Idaho Fish and Game, and he uses a variety of technologies, GPS, radio telemetry, GIS, remote sensing to study movements of animals like skunk and elk. And he got his bachelor's degree at Stockton College, his master's at Florida Institute of Technology, his PhD at Oregon State University. He's worked with a variety of really interesting organizations like NASA, the Smithsonian, Archbold Biological Station, Nature Conservancy, Wildlife Conservation Society, and since 2012 he's been a research biologist with Idaho Fish and Game in this region here. I have heard Scott give excellent talks at the Wildlife Society meeting, and he was gracious enough to come in and lecture to our GIS class or seminar on biology and stuff. Really looking forward to his talk tonight about pronghorn, which was a species that was the focus of Edson Fichter's research when he was a wildlife biologist here at Idaho State. Scott?
Is it back there?
It's in the back.
Well, it's right up against the chair too, so. I have no idea what it is. I was just making sure none of us were touching it.
I'd like to thank the museum for inviting me to give this talk, especially with Edson Fichter. I always have trouble pronouncing his name, and I've had that stutter when I say his last name. for about 10 years or so. Since I did it doesn't click. I've been lucky enough to study pronghorn almost the week I arrived in Idaho. I got thrown into the middle of it and right into the depths of ungulate ecology. And so this is kind of my story a little bit of how I came to appreciate the species as well as the artwork, the poetry, as well as the science and the natural history of Edson Fichter, a little bit better that time, and then also kind of just show a little bit of how his earlier research actually kind of spurred where Idaho Fish and Game is now and where we're going forward, almost from his footsteps from when he left off and some of his final field projects in the Pahsimeroi closed up in the mid to late 80s or so. So I'm always really fascinated with Edson's art. And it's something, it's a little bit sad when you see that things like biological illustration and the importance of that within the field of biology. But, there's something about these images that convey things. They almost convey feelings. You almost see some depth in these, even though these are just, black and whites and everything. And so this is our main character this evening. And so this is what we'll be going into. This is my favorite ungulate in Idaho, that's for sure. Going into the natural history of this, we have to go back a little bit in time. Antelope, pronghorn antelope, are part of what we call as a monophyletic clade. We know pronghorn antelope are the only species alive that are part of their mammalian family right now, and that's somewhat unique. And they're also unique to this continent and everything. And the actual story of this, as well as several of the other ruminant families that we have in mammals, have actually started out somewhere between 20 to 25,000 years ago. And this is kind of what North America looked like at that time, where we had much larger plains. Sea level was a little bit, it changes through, but at 20 million years ago it was a little bit higher. And so this is actually the playscape from which the family of antelope came about. Whoops. And when you start to look, it wasn't always a monophyletic clade. And we've seen this wide assortment of all these different types of headsets and everything, in a really vast variety of different skulls and headsets that were within this family that you kind of don't see. And these are all from kind of fossils that have been found. And basically what I tried to do, and I can't say I did this perfectly, but this is older in time as we go through. And then right about here, we actually start getting into the subfamily of Antilocarpa, and then whereas over on this side, these are, let's see if I can say this, Mercodonids, which is also a subfamily within the family of Antilocarps. So we have this much wider variety of animals, ungulates out on the landscape from this family as we go through time from 20 million years ago, and then probably where the Antilocarpidae subfamily starts to come in is about 10 million years ago. And there were some pretty big differences as well in the size. And so basically, if we go back here, these guys are much smaller stature. We call them pronglets. And then as we start to get over onto this side, we start to get into pronghorns. And that is just a good size reference to see the diversity or how these sizes have changed through time across the continent. Now, not a lot of people from Fish and Game are here.
A lot.
Because I go and I say, well, what's your nearest, sometimes this comes up, usually after 3 or 4 beers. And then it is, well, what's their nearest ancestor, or what's their nearest relative? And I say giraffe. And they just kind of look at me and they don't really say anything. They change the subject. So the nearest ruminant relative of pronghorn antelope are giraffes and ocappi. And there's a recent study that I'm going to highlight here, and this is where I start to go a little bit down into the weeds. That kind of goes back, does a substantial amount of genetic analysis, and as well as protein analysis, and still comes up with showing how long this family has been unique and almost a side shoot of the rest of the ruminants. And so what is a ruminant? And so by these, this is a study by Chen. It's actually the National Center for Science in China. And so the first thing is that you have teeth that have roots and crowns. And the next thing is that you have a 4-chambered stomach. And that 4-chambered stomach is pretty important as far as defining the whole ruminant clade within mammals. And we kind of use ungulates and ruminants interchangeably today. We also have some things here as far as horn structure. And then I'm going to start passing this around right now. So this is a pronghorn sheath. These fall off a pronghorn's headset probably in about the next 3 or 4 weeks. If you get lucky, you can find these out in the desert or so. And part of this is it's a pretty unique way to have a headset. You see antlers that fall off, or when you start to look at bovids and cows or even goats, you have the horns that are on their skull for a long time. And this is one of the things that makes them somewhat unique. If you feel it, that's all I want you to do, is just touch it and pass it to the person next to you. Get back here sometime. It's a little different there. The other thing that was part of this study is locomotion here, where pronghorn are highly vagal. We've all heard the stories. They can run 60 miles an hour. They developed this when cheetah were in North America, and these vast spurts of speed allow them to escape them. And there are genetic foundations for that. So the other part is what, as we go through here, this is a complete genome analysis for all of these ruminant family classes. This is an absolutely huge endeavor that is amazing. Right up here, guess what that is? That's the pronghorn right here. And so that's how separated they are from the rest of the clade. Over here, we have our giraffe and our okapi. And so that's how I can sit there and say their nearest relatives are giraffes. And I have people in China, National Academy of Sciences, that have done home genome sequences that will support me now. Well, what's over here, and it doesn't come out, but the stronger points can, is within these, across all of these ruminant species, is the darker lines show the stronger genetic similarities across these groups. And again, you see this strong connection between antelope, pronghorn, and giraffes, whereas over here are cervids, our mule deer, our elk, our white-tailed deer. They're still kind of over here. They're actually a little bit more closely related to cows. So when you start to think of that, you can see my friends from Fish and Game are being a little bit more quiet now. The other thing is that horn sleeve that's being passed around, it's made of a protein called keratin. And it's not unique among the ruminants, and actually a lot of the bovids have it as well. And basically what this shows is that there's just a random G point mutation across a larger, humans are here and horses, but it's basically this one amino acid sequence change that allows both pronghorn and other ruminants and bovines to have this. And so basically this is a spontaneous change that's occurred as the families have diverged, and it's come up several times. This over here is basically what I'm calling batch mobility. This is the mitochondrial electron transport chain, you know, and this is great to say after, I haven't had to say that since my first year in college biology. And so they're actually comparing pronghorn to antelope, the family of it. And so basically what they have here is provides all the energy for all your cells, for all the work that you do. And they have some things that are shared, mutations in this that allow this to have these quick amount of energy available. But then as well as you can see with the pronghorn, they have a higher variety of mutations here that allow for this speed burst. And so pronghorn are unique, and they're only here in the West. And we're lucky to have them in Idaho. As we get into the recent history, there weren't always as many pronghorn as we see today. And we can say, we can talk about things like Idaho doesn't have as many pronghorn as Wyoming. In fact, Wyoming probably has somewhere between 100 to 1,000 times more pronghorn relative to Idaho. And a lot of this has to do with environmental conditions and water and having better vegetation available. But pronghorn almost went extinct about a century ago. And across the West, we had vast, mostly it was unregulated hunting. We didn't have state agencies, or they were just starting there. And it was actually through the work of some sportsmen's groups and everything that actually started to blow the horn. It's just, hey, we're losing a lot of pronghorn. And this is not unique to the ungulate species in the West. We took out somewhere between 20 and 30 million bison. Similar thing with elk. There's probably more elk in Idaho today than there were 100 years ago. Similar things with other ungulate species. But with these state in just the change of the century, sportsmen's groups, state agencies, and federal agencies helped recover a good portion of these populations throughout the West. And this is also kind of one of the greater conservation management success stories that I can think of in the West, but it's a little less heralded. These were some photos that I was able to dig up here. And, these are actually, sportsmen, but, these guys are fawns. We have a fawn right there. And then even after there was a great effort to stop all hunting across the continent for pronghorn. There's like one or two little fawns that are stuffed under here. And then this was in Alberta, Canada. And I only put this as 1912 plus. So this actually could have been legal hunting that occurred in the 1930s. But this car right here, a little bit of a car buff, is a 1912 Franklin. It's an air-cooled car. And any of you that have ever played around with Volkswagens in your earlier youth or so, what are the chances of an air-cooled engine lasting 25 years? There we go. And so what we have here are some of the earlier assessments of pronghorn and their distribution across the whole continent. This here was done by the Bureau of Biological Survey. As of 1946, we call this the BLM. And so there was a name change there. And just as an assessment, I always call these kind of old Grinnell maps of the species distribution. This other gentleman, Hornaday, actually saw this dramatic of a difference, if you can imagine the dots representing population sizes. This is just a 10-year difference between 1904 and 1914. So things were getting drastic. We were starting to lose major portions of their range. You know, we are very, very lucky in this country to have somebody such as Theodore Roosevelt to actually start the conservation movement. And here he is, he's hanging out with burros here. This is at Fort Yellowstone, right about the turn of the century. And, you know, this was a meeting not just about bison and their great demise or the wonders of Yellowstone, or for Theodore to go run out and try to bag some mountain lions when nobody was looking. But it was actually to think about ungulate species across there. And I came across this great little quote, and it's kind of had to do with that the hunting pressures had occurred were so hard that they actually started to change the behavior of animals. And this is kind of common for animals that have been overhunted. I think of similar things with like things like river otter and everything else. You don't see them very much, but when you do, you're very lucky. And in some places, the pronghorn now seem to have learned wisdom, for the slaughter among them has been so prodigious that their survivors have radically changed their character. Their senses are keen as ever, and their wits much keener. They no longer give way to bursts of panic curiosity, and they cannot be attracted to any amount of flagging or the appearance of an unknown object as formerly. And so these guys are kind of inquisitive, and I've had things where you can kind of, if you're lucky enough, you can flash a mirror and they'll start to come in and check out what's going on in the field. So to that extent, it changed the behavior, but as well, this isn't uncommon when we see things, collapses of this size. So for pronghorn management in Idaho and the Upper Snake River, I showed you some of the pictures, the analysis of Hornaday between 1904 and 1914. There's another person, Selden, who came through at the turn of the century and toward Idaho in 1902. To the best of my knowledge, Idaho banned pronghorn hunting in 1903, and that lasted until 1934. And so, also currently, we are doing the first full-scale reevaluation of pronghorn management within the state. In the past, I think the last one was done in 1991. And so I'm really looking forward to my work with this, and it's one of the more profitable parts of my job. Getting into kind of Edson Fichter right now, and the Pahsimeroi and the Upper Snake. This is kind of the lineage of all the studies that have been done on pronghorn antelope across the plain about an hour and a half to our west. And so we can see Fichter had pretty prodigious amount of studies. Auden Reich was his, I believe was his grad student disciple that worked with fish and game for a considerable amount of time until the mid-80s or so. And then these guys here, Hodgkinson and Tester, actually did some of the first movement measurements out on INL. And then I think I'm in a pretty good spot to where I've got a couple papers or so, but I just got to get my button gear and get them out. And this is kind of what pronghorn antelope across the state of Idaho is kind of their trajectory. What we see is this, during this long conservation period, this is a long haul to rebuild these populations across the west and in Idaho. It wasn't a, we stopped hunting them and then they just jumped back up. So this was a really long thing until we hit a high point at the end of the late 80s, early 90s. And so then these are where some of the depredation hunts started. And by management, we took the pronghorn populations down. And we've actually had some trouble trying to get them up where we wanted to elevate these populations. And then in other places where we don't necessarily need any pronghorn, they're growing exponentially. So we think you know something, go figure. All right. This might, let me see. So, let's see. This is going crazy. Yeah. There's a lot to do, a lot of work in the Pahsimeroi Valley. And so this is across the Snake River Plain within our mountain valley systems. It's right in the middle. It's one of the more splendid places to be in Idaho, in my opinion. If you ever have the chance to go there, and it's hard to get there, you have to like consider things like how you're going to get gas before you get in there, and how many days you can stay, and things like that. But it is a very, very special place. Gives you these grand vistas that you can't imagine. And it also contains probably, it's like the densest place for almost ungulate species richness. So if you don't like pronghorn, that's fine. Go look for mule deer. You don't like mule deer, go look for elk. You don't like elk, go look for bighorn sheep. If bighorn sheep don't do it for you, you can go try to see mountain goats. And on the good days, really, really, really good days that you're alive, you might have an opportunity to see some of these all in one day. And so this is a very unique place, even today. And so this is just kind of like a panoramic view. There's my son and wife and my dog right over there. And when we get into Edson Fichter's studies, what they're more interested in is mostly vegetation structure and composition, and how important vegetation was to being able to successfully raise their fawns. And you know, there's still a considerable amount of grazing in the Pahsimeroi. You can kind of see these are kind of little scraggly sagebrush right there. They're not providing much cover. Provide some nutrition. See, pretty dirty here. Not much grass or forbs or anything going in there. So there's still some challenges as far as, wouldn't necessarily call this the luscious of vegetation to go forward. This is, again, is one of the reasons within this effort to increase pronghorn studies, pronghorn populations across the West. They were keying in on this structure as something that might be limiting population increases. So these are the fawns. And so give you a couple seconds to look at all the different forms and shapes. And if you want to catch a fawn, you can. Even though pronghorn can run 60 miles an hour. But you kind of have to know what you're doing a little bit. These are a highly social species. You rarely see less than 10 of them together at a time. Except if you're out there in late spring, say around May 15th or so, you go out into the shrub, into the sage, and you look for just a single doe sitting out there minding her own business. So what you do is get up on a little hilltop, pull out your scope, you watch. And then you watch. And you watch a little bit more. And eventually, if you're right, which she could just be antisocial, all her friends don't like her anymore. But then she'll come in and she'll feed for her fawns. Nearly something as high as like 90% of all pronghorn does give birth to twins. It's very rare that both those twins live. Part of their behavior, and this is really unique to go through, is, so this is a little bit unique in that we have two fawns right there with the doe. Usually it's a single one and she'll come in. So they've been separated for upwards of 4 hours or so. And so you would think the first thing that would happen is that she would start to nurse. This is what happens. So she comes in, and then the fawn urinates. She actually drinks all the urine. And then the fawn defecates. And she eats all the feces. And then they get her out to nursing. And this is a way, a behavioral strategy in order to contain all the smells that are involved with that excretion. And the reason why that's happening is because predation in these first 3 days of life. And there are 4 days when these little fawns are very immobile. You know, they can get up and they start to get around, but you know, they're not running around at 70 miles an hour yet. And some predators take advantage of that. Now this might be rare. This is how we do this at fishing game, and how we go about after we watch this. We've located where the fawns are. And let's see if this video might work. We need my little touch.
I'm going to let you do the touch.
All right, here we go.
Okay.
All right, the Fred Brent painting on the right, Curtis Hendricks will be on the left. You can kind of see, this is at dawn, so it's very hard. And so he has a big neck. And then we're very quiet when we do this. We have very good hand signals to one another on where we want people to go. There's Curtis. Kind of hear the birds a little bit. And just kind of sneaking into this bush that the pronghorn is hidden under. There he goes, it starts to run, and they're able to do that. And so the first thing is we've got to shut the thing off. This mother came running up right past me, was right here when this was happening, and I was taking the video, so that was quite amazing. And so this is some of the processes that we do, and the same ones that Edson and some of his crew did in the mid-70s, in order to put basically these VHF collars on these fawns, so we're able to go out there and find them later. You know, they kind of tend to quiet down once we put a sheath over them, so they can't see anymore. And we do all sorts of cruel things and take measurements and weights and stuff like that. We're very careful with our scent. That's one thing we've improved upon from the past since Edson's time out there, because we do recognize how detrimental it is. You know, you can see the rubber gloves. So basically, we're trying to go in there, hit them with this very small, tiny VHF collar, and then run away. And then, really lucky, you have a good friend. You know, see, whoops, still have the rubber gloves on. I'm not really kneeling on the ground yet, spraying my scent. We're very careful about these things. You grab a great photo, and then you get to go home, and it's like, wow, I did something cool with it. You put the phone down, you walk away, and then always, you know, you're leaving it there. We'll go and monitor these things, locate them every day with a VHF collar to see if they're still alive. And so the tone, the beat, the frequency on the VHF collars, it changes when if the collar hasn't moved or hasn't jiggled in say 4 hours or so. So then that the animal's probably dead. We have to go in and get it. So in this vast expanse of emptiness, you know, you're just kind of this little fawn, cute as a Labrador puppy, hiding under a bush. And I just love these next kind of sequences with these drawings from Edson. Just look at the eyes, and just kind of, this is what's looking for them right now. This is the easy meal for them in spring. So black bear. And this didn't come out as well. Bobcat. And then also probably the master of all the denizens is the coyote. You know, these guys are smart enough that they're watching you. They're smart enough that they know if they smell you around there, that there's probably a pronghorn fawn around. So we go out there every day, and we check them with the VHF collar. This is neat. Here's the VHF antenna, and basically what I have is the radio right here that will let me hear the beeps. And you know, usually when you don't hear something, you go up to these higher mountain tops in order to try to figure out where this one might be. You might be able to get a fake signal. So I'm pretty sure that's what I'm doing right now. And they don't all live. And there ain't much left most of the time when we get back to where they are or were. And we go in there and we try to collect what information we can as far as what caused the mortality of that individual at that location. And sometimes this is all you're left with, you know, so what happened? Other times we have a lot more information as far as if you have more of a carcass available, the necropsy and what had happened. And so this is kind of some of the job that we have to do when we find these mortalities. And then the most important thing is you get the collar. You don't come back in without the collar, because then that's going to go out next year. And, each one of these things is maybe $200 or $300, but we always bring the collar back. And so there's a recent study by Brett Banting, was a recent grad student, worked with fishing game. This is his master's thesis, and he looked at 3 sites across Idaho, so Big Desert, as well as over near the Camas Prairie near Fairfield, the Camas up north of here. And these are the main causes of death for pronghorn fawns across the state. And so, you know, the big message is you know, kind of golden eagle came out a little bit high. This is almost exclusively the Pahsimeroi, bobcats, black bears, and then coyotes. This is the biggest thing. So we were trying to figure out, you know, exactly is fawn survival, that's really what limiting how fast the population of pronghorn comes back. And basically what we found out was a couple of things across the state. Is that if you're a fatter baby, you have a fatter fawn rather, you have a better chance of surviving. Again, this kind of goes back, and it's a little bit circular, but how are you going to get fat? You're going to get fat because your mom has enough nutrition. How does your mom have enough nutrition? She has enough vegetation to eat, and high quality vegetation is available to them, so that their birth weight is high. And if you have a higher body fat content, you have a higher weight, you're going to move around faster, you're going to get up quicker. This was a surprise here. If there's other things to eat, you have a better chance to live. So what we found is the abundance of lagomorphs in the area, rabbits, actually serve as an alternative prey for coyotes, primarily, but also as well as bobcats. And this was the second most important factor that was involved there. And then finally, again, you'll have a higher survivorship if you have a lot of high quality vegetation in the area. And the way that we measured this is basically, we call it DAPA, diaminoethyl alpine acid. Basically, it's where you can go collect feces, fresh feces, and you're able to figure out how much protein that animal was ingesting immediately. And so again, circling back to some of Edson's work, vegetation is at least driving some of the 3 legs on the stool here, as far as the body mass index or the birth weight of fat babies, and as well as the environment that they're grown up in. Here we have a little bit more structure in the Pahsimeroi, one of the nooks and crannies. Here we go. And this is from Edson's his final Pronghorn Coda, 1987, here, where he had the chance and the opportunity to go and actually start mapping out in time and space of how these animals integrated and acted socially with one another. The number of does and the number of fawns and even the number of bucks that would come and greet each other in a temporal sequence. In each one of these locations, I don't expect y'all to memorize them. I don't think I can memorize them. But essentially what he did is, this is basically how social they are in the morning, and he maps it out through afternoon. Which individuals or how many of them are meeting where. This is before GPS. This is actually even before the VHF actually worked, the radio collars. This is about 1965. And so how all these groups, as we went through the day, changed, met, left, got lost. These are question marks. I thought that was an incredible act of honesty. You don't see that much anymore. And again, going back to the numbers again, how these things move through the afternoon in their interactions with one another. And you think about it, this is how he was doing that. So, those are 6-hour trends that you see going on there, but high deal of focus. It shows a different type of dedication to your field studies that necessarily I don't have with the technologies that I use today, with GPS collar technologies and locations and satellites and data transfers and everything else like that. So there's one thing he didn't study. This is kind of where I get into things, is where a lot of movement, and how these animals move, where they move, why they move, how far they move. And this is still something that's quite a little bit of a mystery for those pronghorn that are in the Pahsimeroi. We haven't exactly figured that out just yet, even with our VHF collars. We haven't had the opportunity to put on a year-long GPS collar that would track your locations like a cell phone does to you, but does this all year round for a pronghorn. And we get the collars and we get the data, or it's actually now transmitted up to satellites where we can retrieve it. So I put this as a pronghorn migration mantra. I think this kind of goes to pretty much a lot of the ungulate species. So most native Idaho pronghorn migrate. A good proportion of Idaho pronghorn basically move to higher elevation sites in the summer so that they can benefit from higher vegetation nutrition. They move from the summer in the winter to basically escape high snow depths. And with pronghorn antelope, they're very interested in running very fast. They can't run very fast. They don't want to be there. This behavior, moving between the higher and the lower grounds and shifting, allows this species to basically exist in higher numbers on the landscape by exploiting these two, sometimes very separate habitats. And then this is the other one that I think is critical right here. They learn their migration routes from their moms. And so it's a learned behavior. It's not a genetic behavior. You're not going to sit there and hand raise one and then put it out there and boom, away it goes. They learn this. And this also comes in, we've seen similar things with bighorn sheep and also with moose across the West. Whereas those ones that have been introduced or reintroduced to areas, we can almost see it takes them, say, I think with our friends and colleagues at the University of Wyoming, they've shown it takes upwards of 200 to 250 years to learn these seasonal migration patterns that work for them. 250 years to gain that knowledge once it's been lost. And it's knowledge. People don't think of things like deer and pronghorn and elk having knowledge. So it's one of these things that if we lose it, it's going to be a hell of a long time before we get it back. Also, when we start looking at pronghorn across the other suite of species that we're able to gather data on, basically, this is how far on our y-axis here pronghorn are moving, and then this is basically, we start out in January, over here to December. And when they're migrating, like this would be in their winter habitat, spring migration, this is their summer range, and then they drop down here. This is how pronghorn compare to all the other ungulates in Idaho. This is an incredibly condensed amount of data. It's a little silly, ridiculous, but it's 750,000 locations across all these species. I had to go through to figure this out and get this thing going. It's a simple thing. But that's basically how they rank out. And so basically the first ones to migrate in the spring, they get back midpoint, but they also, on average, will migrate further than all the other species. And I do have to update this stuff because I have about 4 more years data that needs to be incorporated into that, and that's part of what we're doing. So this is basically a cast of does that are migrating in the spring. It was out near Lava Lakes Ranch outside of Arco. You kind of see this one here has the GPS collar on it. I was really lucky to get that picture. And this is some of the migrations that this population had done, or how we measure portions of this population. Created the Moon National Monument right here, the foothills of the Pioneer, small town of Arco right here, the other town of Cary. These are what the GPS collar locations come in. We can start to then assemble, basically we call this utilized distribution, but just basically a big probability map that there was a pronghorn in there. Then we can assign different frequencies, 75%, 50%, 95%. And we can put the paths in there. And so this is in the fall of 2008, and they returned in the fall of 2009. We did another round, they used the same path, and then they come back the exact same way. So for this one extremely narrow section, in places it's less than 200 meters wide, this whole population is funneling in and out of here. When you start to look at their migration, so this is a little goofy to see the north arrows like up over here. There's about 5 or 6 different land management agencies, from private land to the National Forest Service to the BLM to the Department of Energy, land who they're crossing over on their migrations. And their summer range down here versus their winter range further to the north. They're not going to go across lava. None of the ungulates like to go across lava. It's just, if you ever walk across some of these lava fields, it becomes pretty apparent within about 20 feet or so. I wouldn't want to do that. And we're able to start to decouple and start to take out the parts of these migrations when we start to look at them. And basically, the hotter the colors show is time when the animal spent more time there. And you can see that we have, places where they stay longer, and then areas that they transit through rather quickly. So when we think of migration, it isn't this one constant with pronghorn. It isn't one constant march off until you get to your destination, but it's a series of rest stops, areas where you cruise through very fast, and then you go and you rest again. And so these areas now, we call them stopovers, and then these other areas, we haven't come up with a term as sexy as stopovers, so we just call them transit zones, for lack of a better thing. And why are they going up north? Like birds are going south in the winter. Remember, so this is basically, you could measure snow every day in Idaho, and get an estimate of that, and add that up, and then take the average across a year. What would it start to look like? So we did these averaged it out every year and figured out what the maximum snow depth was between 2003 and 2015. Again, like the way that this works is the hotter colors are deeper areas of snow. So right here's the Pahsimeroi, the border with Montana. You are right about here, and you know, how deep on average does that snow get? You can kind of see there's this little line right up here, right? It goes from the base of the little Lost Valley system, which is the other side of the Pahsimeroi, and up into Birch Creek. There's this little part right here that doesn't have much snow. And that seems to be one of the major winter refuges for the upper Snake River Plain. And a little bit bigger view of that. These other areas here, these are just lakes, so they don't count for snowfall measurement. But again, like I said, they're going away from these deeper snowy habitats that occur where the better vegetation is in the summer, and they're escaping those in the winter. And this is kind of, I believe this is at the base of Crooked Creek, so this is this northern area where they stay in the winter. And they can get quite concentrated here. And basically what you're seeing, where these are basically, what I've shown you so far is just one little small population that occurs outside of Cary in the Littlewood Reservoir. And this is going up into the base there, somewhere between Howe and Crooked Creek. But there's several other populations that are doing this. So in the wintertime, you can actually see fairly large aggregations in the range of 600 to say 1,200 animals. But those are also aggregations. It's not one big population because they're not mating them. It's actually an aggregation of several smaller populations. So that has implications as far as the population dynamics and their trajectories and the reproductive, how fast they can reproduce. And so when we start to look at this a little bit better, these blue dots are basically their winter range coming in from GPS collars. And these red dots are for the collars that we retrieve where they spent their whole summer. And so you can see these guys over here that went past Craters of the Moon National Monument. They came up and went this way. But we also see that they're going up into Montana. Not one, two, but 3 different places. Seems like they're going out right towards the freeway. There's some blockage there. They're also coming down right outside Blackfoot. And then we also have one individual who kind of doesn't really do anything. Just so happens that there was also a reintroduction into this area in 2005. Maybe they didn't learn from their mom. Maybe they just weren't social enough to learn from their friends. And so when we start to add this, when we start to look this up, when we add up all the stats, it's like, you know, on average they're going about 70 kilometers. And this is basically crow flies distance. Start here, go there, measure in between. When we start to measure all the leaves and waggles that are in between that, we actually get, you know, kind of a maximum migration distance that was in the 240-mile range or so. A third of these go up to Montana, as I showed. A quarter of them went back down to the Littlewood Reservoir, then went to the Pahsimeroi. And the reason why, I think, pretty sure, you think that this is the Pahsimeroi is that there's probably a much closer area there that has very light snow environment right outside the surrounding shallows. And it's much more likely that there are individuals there in the winter. But we haven't had a chance yet to go and get some data on them in the winter and do some captures. So there's big interest now in how ungulates migrate across the west and, you know, whether there's some barriers. And barriers aren't all caused by people. So this individual here moved from this Crooked Creek, and this is up the West Centennial Valley in Montana. So right here is a high divide, high 15 goes up right through here. You see, this individual kind of had a couple of stopovers, went up and then did this, and then turned around and came and hung around here for a little bit, and then just hightailed it all the way up over the divide in one day. And just keep an eye up, well, it's hard not to, but where the star is. Because then when we start to look at some of the snow maps, this is from SNODAT's data system that's maintained and used also by NOAA. We could go look at the date, which is like around May 3rd. This snow depth where she was trying to go up across was right about at 17 or 18 inches. And that's right about where Pronghorn, as well as we know, kind of put the brakes on their movement. They're not going to go, and they're not going to go over that, through that. When she came back in the fall, she had the wind at her back. She came right back straight down. Didn't go this longer route around I-15 down around that one. And so to me, this was kind of amazing. Right, so you have weather there blocking the migration. But the other truly amazing thing is not only did she know one route to move 60 miles or so, she knew two routes. And she was able to use that to her advantage. And so I still ponder that all the time, because as I go through some of the other stuff in greater detail in my studies, I'm also seeing other things. It's just how the vast amount of information these animals must know about their landscape and how to navigate it. There are other barriers to migrating. Some simple fence structures, wire fences across the west. It's pretty simple. A lot of fences in the west, but surprisingly, for an animal that can run 60 miles an hour, they can't jump over a fence. It actually has some considerable mortality within winter range. They get hung up on top. They tangle up there, and it looks like a pretty awful way to die, but they go under the fences. And so there is a larger effort within the Pronghorn community to get these barbless wires and have them up over 18 inches so that they can transit these fences. It's also interesting that it's some of the more amazing things. We capture these with helicopters, and I've seen them come up to these fences, and while running 45 miles an hour, gets up to the fence, stops, goes under, boom, shoot, and just goes under. It's being chased around. Pretty amazing. And then the other thing is where we run into roads. Basically, it doesn't come out too well here. This is an overpass that they built. This is Trapper's Point. This is out of Pinedale, Wyoming. This is pretty amazing. They turned a high collision area over now, and it's actually a tourist attraction. And then that's it. Yeah, it should go. And so not only that, so basically this camera is up here and it's facing down over here. And what we'll see is that these animals coming up, and then you see our pronghorn over there. Yeah, they are. They're a little slow. I think they are. We just watch. They should. Is it coming?
They're gone?
No.
Well, it does. Very slow.
Yeah, I did pretty well in the first one. I'm sorry, guys. But basically, what you would have seen.
Oh, there they are.
There you go. It got clogged up. Basically, these guys come in and they just run very fast right up to there. This is pretty much a great accomplishment, at least in my brief lifetime in studying these guys. We didn't know this 10 years ago. Seeing these things, be able to cross these things at such speed and frequency, and be able to use this as they have to navigate the landscape, as they do these seasonal migrations. It's also amazing to see this turn around, where once upon a time, this was like a very dangerous area, just something, you have to worry about. You get dents in your car. Now it's a tourist attraction. Now this is live. You can go on there now and see what's happening at the Trappers Point overpass, and that they're recording this, and that these things work as a way to mitigate their migration. Also, we have this thing, and this is getting close to the end of my talk right now, is our current work. Probably under Department of the Interior Secretarial Order 3362, the last existing order that's still in place by Director Zinke, was to look at and try to preserve all the migration routes for pronghorn, elk, and mule deer across 11 western states. And so with cooperation and opportunities provided by the federal government, we were able to hire a couple of postdocs, and now I'm working on a weekly basis with University of Wyoming, the Migration Initiative folks, to actually not just map out single individual migration routes, but actually start to do this then again at population levels. So again, these hotter colors represent areas that are used more, or at a higher proportion across the population, but then still trying to preserve where those migrations occur that we know of. And then, you know, just how we integrate this across several different studies, across several different years. And then also in here, it doesn't come out too well, but these little red spots here are kind of the population level stopovers. These are stopovers that we see more than one individual using. These are the areas that they're resting, they're gaining energy, they're eating, or they have to go through other areas of transition. And again, so still upwards into Montana, as well as over down towards Cary, and then as well as out to the outskirts of Blackfoot for this one winter herd. And so there's still some questions to do with this. For pronghorn antelope, we've expanded this out this past spring to putting collars on the Boise front. And we also did another major collar, deploying collars this past summer, based in Blaine County in and about the area of Fairfield. We were also able to get a couple collars out on the Oahes, which even in Idaho, which is quite remote, the Oahes are very remote. So this is kind of some exciting things, because I think we already know that some of these guys are moving down into Nevada. Some others are going over to Oregon. And then the other thing is that it isn't just for for pronghorn, it's also for mule deer and elk. And this is a statewide effort. So hopefully once we're able to gather this information, make these estimates and these delineations, then we can start to assign appropriate land management so that these things in this migration, this seasonal migration lifestyle is still possible across the state of Idaho. Because it's really, in my view, don't say this is fishing game, say this is Scott Bergen. But in my view is we really we put a lot of effort, a lot of our logistics, a lot of our talent into managing animals that are residents. And those residents are the animals that are going to eat our crops and our crops in the summer. That hits us really hard financially because we end up paying for that. They also end up, we go and we look at mule deer across the Bannock Highway there, considerable amount of wildlife vehicle collisions happening on a daily basis. We're engaged with the town as well as how do we manage this problem and everything. And it's not like we can come out there like Yosemite Sam, guns blazing, and then go cure the problem. It's something that has to be managed and has to be dealt with, and that takes resources. So that's another reason why it's really important to maintain this ability for seasonal migrations across these species. So I really wanted to try to look into this. My aim of the talk was to at least remember that pronghorn are unique, even though my friends don't say anything to me about it. Pahsimeroi is a pretty unique and beautiful place that has rich and diverse ungulates and is especially pronghorn populations as well. And that, you know, this all came about through the studies of Edson Fichter. Fichter, thank you. And his artwork. And that hopefully you're a little bit more familiar with that. And with that, that's about all I got.